Hello and welcome to this video. Today I will show you how I made this door lock system using the Atmega 328P AU chip. I used a 4x4 keypad to enter a password consisting of 4 digits. Pressing the hashtag confirms the password, and if it is correct, a green LED will illuminate for 5 seconds, as well as a servo motor will change its position from 0 degrees to 90 degrees. While the user is not interacting with the system, the red LED will keep blinking every 1 second to indicate that the system is locked. I started this project a year ago, and now I want to complete it by making a PCB and an enclosure box. I used the online PCB design tool EasyEDA to design my PCB. I choose the Atmega 328P AU chip because I didn't want to occupy a big place on the PCB with the Atmega 328PU chip. Feel free to download the Gerber, BOM and CPL files, the link in the description. For the enclosure box, I used an online CAD software called Onshape, which is free to use and to download the STL file. I ordered my PCB from glcpcb.com and activated the PCB Assembly service. I preferred not to have certain items pre-installed by glcpcb and choose to solder them myself upon receiving the PCB. glcpcb also provides a 3D printing service, so I proceeded to upload the STL files as well. And then I choose the SLA, resin, 3D technology, and CBY resin material. Before ordering my 3D model from glcpcb, I tried a local 3D printing service, but the result was not satisfying, as I faced issues with fitting the nut into the screw pocket and the LED into its designed hole. This is why, as soon as I received my package from glcpcb, I immediately verified the dimensions, which were perfect, as well as the PCB and PCBA. I used an Arduino Uno as ISP for sketch upload. You can find the connections between the Arduino and the board in my blog post, Arduino-based door lock system, or by clicking the link in the description. I connected the Arduino Uno to my computer and opened the Arduino IDE. I went to File, Examples, Arduino ISP, and opened the sketch. Selected the board, Arduino Uno, and the port the board is connecting to, and clicked Upload. Once uploaded, I headed back to Tools again and selected the board Arduino Nano, the processor Atmega 328P, the port the Arduino Uno is connecting to, changed the programmer from AVR ISP MK to I to Arduino as ISP, and clicked Burn Bootloader. Finally, I opened the desired sketch to upload, and from the menu bar in Sketch, I clicked on Upload using Programmer. Click the link in the description to download the sketch and to watch the explanation video of it. I painted the 3D printed parts orange and placed the nuts in the designed pocket. Stick the board with double-sided tape. Regarding the step that involves securing the power and servo wires beneath the bridge constructed within the enclosure box, took me some time and patience. It made me think of changing the PCB footprint and 3D part design in the future if I want to make version 2. Now that I am left with positioning the LEDs, securing the keypad in the right spot, and connecting the pin headers, the satisfaction of seeing my hard work comes together was incredibly rewarding. This is my project, everyone. I hope you will build it also. And now I bid you all to like this video and subscribe to my channel. And goodbye.